the balancing act. Understanding the center of gravity. Have you ever wondered how a 250,000 kilogram stone in Tamil Nadu balances on just 2 square feet of land? Why does a tightrope walker carry a long rod? And how has the Leaning Tower of Pisa remained tilted for 850 years? The answer lies in a fundamental physics concept, the center of gravity. Think of balancing an object. Through trial and error, we find that one magical point where it stays perfectly steady. This point is the center of gravity. For symmetrical objects like circles or squares, this point is at their geometric center, making them easy to balance. But is the center of gravity always inside the object? Let's test this. Take 2 forks and interlock them. It might seem their combined center of gravity is inside, but it's actually outside the physical body, near the intersection. According to the definition, if you balance the object precisely at its center of gravity, it should hold, and it does. This shows the center of gravity can lie outside an object. Another example is a cut ring. Its center of gravity is in the empty space inside the ring, literally in midair. By supporting it exactly at that point using threads, it balances perfectly. So, a body's center of gravity can be inside or outside its form. How to find the center of gravity? For asymmetrical objects, we use gravity. Hang the object from a point and attach a plumb bob. The vertical line it creates is the line of gravity. Mark this liney. Now, hang the object from a different point and mark the new line. The intersection of these lines is the center of gravity. Balance the object on this point, and it holds steady. Stability and the line of gravity. An object remains stable as long as this line of gravity passes through its base. Tilt it too far, and this line falls outside the base, causing it to topple. The Leaning Tower of Pisa, despite its tilt, is stable because its line of gravity still falls within its widened base. This principle applies to humans too. Try this. Stand with your heels and back against a wall. Without moving your feet, try to pick up an object placed just in front of your toes. You can't. When you bend, your line of gravity shifts forward, beyond your feet, making you lose balance. To succeed, you must step forward, bringing your line of gravity back over your feet, lowering the center of gravity for stability. Balancing a pencil on its tip is hard because its center of gravity is high. But attach a heavy weight to its bottom, and the system's combined center of gravity drops below the contact point. Now, it balances its... This is why tightrope walkers carry a long pullet, lowers their system's center of gravity, increasing stability. Similarly, a simple ring, you imbalance on a rope because its center of gravity is above the contact point. Insert a straight rod through it, and stability improves slightly. But bend the rod downwards, and the system's center of gravity shifts below the rope. Now, the ring can roll along the rope smoothly. In summary, the center of gravity is the key to balance. The line of gravity determines stability. By manipulating the center of gravity, sometimes even lowering it below the support point, we can achieve remarkable stability, explaining everything from ancient monuments to thrilling circus acts. If this explanation resonated with you, your engagement encourages more such content. Thank you.